Hello, fellow problem solvers. So today what we're going to be doing is continuing our Connect 4 game, and now we want to make so that we can play the game with ourselves, but we also want to make some sort of initial AI. And we also want to clean up everything here just to make sure that things look much nicer and that we can work with them in a better way. So that's what we're going to be doing now. And before we do anything of that, what we need to do is we need to come up with a plan. What are we going to do? Like, what is it that we want? So, what do we want? We want this game. Sure, while this game is on. So instead of this being an integer, give me a move, we want to take a move in a general way. And we want to say like that you could play either player, like human player versus human player, or human player versus some AI player. And what we're going to be doing with the AI player, what we care about is that this player gives us a move. So how are we going to do that? Well, we are going to, the best, easiest way I sort of see right now of how we can like think about what a human player is, what an AI player is, what a player is in general, is let's think of them as classes. Class of human player. And what we need to do for a class is we need to initialize it somehow. What do we need? We really only need, at this point, for the human players, we just need the sign. And the sign that where the sign is going to be a 1, a 2, whatever. And we need to have a function that makes a move. So instead of give me a move, we're going to call this function what? What do we want to call it? Give move. And to be able to give the move, we also need to have a board, correct? Yeah, we need to have a board because that is what we are going to be using to decide which move to give. And maybe even the sign, do we pass in the sign or do we say the sign is like a part of the player? I think we can just say the sign is a part of the player. And what we will do is when we have to give a move, we'll just print nice the board. And after we've printed the board nicely, we want to do this thing here. We want to have this input, give me a move, and this is going to be the move. And then we want to do this sort of checking if the move is good. So we want to check if move is less than columns, or actually if move is both less than the number of columns and move is greater than negative. Yeah, we want to say, we want to exit if it's greater than -1. But let's just say, like, let's look at only the values. Let's assume we're giving values right now. So if this is the case, then what we want to do is we want to return the move. And if this is not the case, we want to say, give me a move again. So let's make the move, okay, let's say while true, like a while loop. And then for as long as we don't have a move, that's an integer that works out here, we want to continue on asking for a move. And now what we also want, I think this is what we really want. Oh, yes, we want to know which, the sign we sort of will know as the player. We can say, give me a move. Your sign is self.sign. And now we have like some sort of human class that we can maybe use here. Now, we also want to sort of get, we can do it like this at this point, but we can also put this all of this inside some big function. And we also need to, let's see, what do we have? We have the number of rows and number of columns as these, they're called global variables. So let's think about, let's take a minute sort of to look at our code. I invite you to, if you have this code, pull it up. If not, I will put it down, I think, in the video description at the very minimum, if not on a GitHub repo. And look at this code and think, what would you like to fix? How can we organize this better? And take like a minute or two and do that now. So the thing we're going to be thinking about doing here is, well, this game, we can wrap it up in a function, but we can do that later. Let's just get some general sort of high level what we want. We want this human class and we want an AI class. Oh, also, wait a second, this doesn't work out. This doesn't take stuff as input. Let's first print like your sign is, because the input part does not take other arguments. Your sign is self.sign, and then give me a move. So it will print nicely the board. Let's first check what happens if we say, okay, let's call it, say, A is like a human with sign 1. Like, we're not really using the sign at this point, but let's just see if this sort of input works right now. A dot give move, and we need to pass in the board to give a move. Let's see what happens. Yes, your sign is 1, give me a move, and then bam, you give a move. Beautiful. So this thing works. Oh yeah, now this won't work. Well, I'll just do an error. Okay, so now we have this. Now I also want to make sure, so we're going to be having this current player is no longer going to be current player 1. There are going to be 2 players, like P1, say it's human 1, and let's say P2 is equal to human player with a sign. Let's actually use different signs just so we know that these things work. Say X and O. And now the current player at the beginning is going to be player 1. And then what are we going to have? We're going to always have the current player give the move with the board. And if the move is good, and I think the move will be good because we're checking it here, but let's just leave this here. If the move is good, we will never come here. Actually, if we know that the move is going to be good, let's just take in that good move. Like, we don't need to check anything. And then we want to make the move with the board move and the current player. Now, what we've done before with the current player, like when we click make move, we have a move number. This is really the sign of the current player that we're putting in. Now we're going to print the board nicely. We can also skip this because we're going to print the board before we get the move. And now we need to switch between the current player. So how do we do this? Well, one way of doing this is to say, okay, these are players 1 and 2. Let's put a little array, players being an array of P1, P2. And now we can just keep switching the index back and forth, like current index is going to be 0, and then the current player is going to be of players with the current index. And then we're going to have the current player will be, so then we're going to change the current index to what? If it's 1, it's a 0. If it's a 0, it's a 1. So it's 1 minus the current index. And then from there on, we say that the current player is the players of the current index. And if the game is on is equal to not check win of the board and move. Let's see if this works. It would be wild if it worked on the first try. Why is it printing things twice? Your sign is X. Give me a move. Say I'm giving you a move. Here's 4. Your sign is O. Give me a move. Here's 2. Okay, things are happening. Things are happening. Let's see whether or not this actually works out. It's very bad UI. Oh, but it does not check for a win. So we have a little bit of an issue here. It's not really checking if the player has won. Now we need to check that. And I invite you here to pause for a bit, like say 5 to 10 minutes, and see if you can debug this, because we've just changed the sign and now we no longer have this. Maybe for the pause, let's just change the signs here. Let's make it signs 1 and signs, I don't know, 3. And let's do an end of the file. So what do we have? 3, 2, 1. This, and interesting thing, the thing is not finishing up. We're checking the board with the move, check win of the board and the move that was given. So this is actually very interesting. Why is this not working? Well, the board and the move checks out what we have. We find the place where if the current is 0, then we break. Okay. And then it returns a check win here. I'm curious if the column and the row is good. So let's do that. So this is debugging now. Column P. Let's see if this is good. So 5, 4. Let's see. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Okay, so it's found the correct row P and column P. So something else is breaking up. Maybe we've done something here that I forgot about right now. And count is 1. We don't know the sign. We have the count. This is actually, it's very wacky that this doesn't work. But I don't know. Take a minute or two and figure it out yourself. Okay, so after some debugging, I figured out that what the problem was that the only thing that really didn't work was this whole check when column. And that was because here we weren't really checking whether this was in the correct column P. And once we change that, everything seems to be working well. Everything else has a column. And now we have this thing where we have the size. Let's use numbers for now, just 5 and 1. And we can play the game. We don't have to print nicely the board at the beginning. This just bothers me for a second. Let's just do this. 4, 5, 4, 5, 4, 5, 4. And yeah, then we win. And if we win, we want to just like print nice the board. Okay, so now we have something. We have the human players working. We have the current index, whatnot. And this whole thing, we could put it all inside this big class called game, just to like make everything more contained and have an easier way to manage these files. So instead of like having like instead of having everything in one file, I'm going to create a new file called human.py. And now in there, I'm just going to copy this whole class human in here, beautiful. And then we'll import it. And why are we doing this? We're doing this because it's going to be easier. Let's see, import maybe human. Let's see how import, where this imports from human, import the class human. Let's see if this actually works. Print nice is not defined. Oh, yes. Let's import from connect for, import print nice. And now we have from importing human. So now what do? We Google what's happening here. So it seems like we have this circular import, it says. Let's see just what happens when we do this. We just like copy. This is nothing that should be done, but let's just see if it works quickly. Yes, now things do end up working. Oh yes, now the number of columns is not defined and everything. And we can calculate that here. We can say calls is equal to the length of the zeroth of board of 0. Now we have columns defined, give a move. Beautiful things end up actually working. So yay. Now we have this. Okay, this did now work out for some reason. Oh, invalid literal. We can have a try and catch here. But anyways, let's just leave it as this so we can actually exit the game quickly. So now we have this human thing. And now let's also create the AI. So we have a human, a player 1, a player 2. But what we're really still doing is, here we have the players. Let's see how can we create just an general AI Python. Let's see, what do we need? Let's copy this sort of thing, because this is what it's going to be needing at the very minimum. AI, the AI isn't going to need a nice print of the board. It isn't going to be. Let's just have it return actually it's going to be needing the number of columns. Let's just have the AI player, let's import random, and let it just have it return a random move. So how's that going to work? Well, the move needs to be less than the number of columns and greater than -1. So I'll just have it return 0. Let's just have the AI play 0 at every single point. So player 2 is going to be AI with the sign 5. And we also, from AI, import AI, And let's see what happens. I give you a move. Oh yes, the AI is playing here. So this seems to be working now. What the AI also needs is to be able to make good decisions. Well, let's first have it just return like some sort of random move. So we import random and we have random dot random, I believe. That gives us a random integer between 0, random actually, not an integer, random real number between 0 and 1, just a random float. We multiply this by the number of columns. And then let's make this an integer. And now the int function will round down. And let's see what happens. Okay, when we have Python connect 4. Okay, so the player played there. Okay, yeah, it's playing some moves. These aren't great moves. Like this does not have any logic. It would be a very big shame if I just lost to this player. So now we have sort of an AI that's playing something. Now we need to figure out how are we going to have it create smart moves. And for this, we're going to need to go back to our drawing board. But before we do that, let's actually look at this whole thing. So we have a board. Let's make all of this one big game. So let's call it class game. And with a certain number of rows and columns and the players, let's just use players. And what are we going to need in this game? Well, we're going to need to know the number of columns. Whoopsie, that is not what I needed. So we initialize with the self. And actually, no, this is not how this is where we need to have this initialization. Number of rows, columns, the players that are going to be playing the game. And then we'll do something like, okay, let's call this self.rows equals to rows, self.columns equals to columns, and self.players, we'll force this to be an array of players is equal to players. And now with this initialized, we also want to initialize a board. Let's have the board be part of the game. Self.board is equal to this. I think that was in here. And afterwards, we want to call a function play the game. Now, we've played the move, print nice, all of these functions, check if there's a win, yada, yada. Let's just indent all the functions. Now they are part of the game. We're checking if there's a win in the row, diagonal, though. Actually, I'm curious if we want to just like have these checks be performed in the game or like have a class called board. But let's just have them be made right now in the game. And now we have check win, and we also want to create a function called play the game. Play the game with the self. Because I think we would assume that we have, okay, so we have this thing. We have whether the game is on or not. So we have game is on. Let's put that to true. Self.game is on is equal to true. And now with that, oh, I just closed this accidentally. We have game is on is true. And then we're going to be calling self.playGame. Self.playGame. And now let's actually make this thing happen. So what do we need? We need to say while the game is on. This is roughly this is what's happening while the game is on. So now let's actually change this to fit the way we're setting all of this up. We need the current player. So we're going to have the current player is going to be players.currentIndex. So we need the current index. We have the players. Let's make this also a variable. Self.currentIndex is equal to 0. And now with that, we will know what is the current player. And we also let's have like self.currentPlayer. I think that is what we're using. Self.currentPlayer is equal to self.players of the self.currentIndex.
Now what I'm going to be doing here is I'll just speed up this whole thing where I'm trying to replace all the selves that I have into this whole class of game. and I'm adding them everywhere, and at some point I realized, wait, I could just do a find and replace to speed up this process.
And here we have the thing. So we've added cells and removed things where we don't need to solve. I mean, not everywhere, just at some points. Like we're still referencing the rows number here, even though we have it. Just because there's no need to change this thing. I'll just call self.rows. And anywhere we really call the length of the board, we could say self.rows. But yeah, this seems to be working. Now we have a nicer way that we can look at this whole thing. And I've tested this out with the number of rows, number of players. We have 2 players, and now this whole thing works. So now there's a couple of things that we could be doing. One of them is we can also add a little print nice after we're done. Print nice. It just doesn't need anything. It has the board. And we can also print game over. I don't care who won right now, I just care that the game is functional. When print nice requires, it's self.print nice. Now let's see what happens when we play and win. Yeah, game over. So, wait, who won? Oh, the random AI won. So this is actually mildly embarrassing. But hey, it happens, this is, if the AI beat me, that's a good sign. That means I'm a good programmer because I made an AI that can beat me. But now we have this general thing, give move. But what we would really want to do is we would like to create different types of AIs that can play the game. And the first thing that we are going to be trying to do is do a little bit of a Minimax AI. And what is that? That is basically, well, let's go to the drawing board. Basically, the idea is this. You have your board here. And now you can make 7 moves. Like 7 moves in this case, maybe we're going to like generalize this to more moves. And any single move you make, say this is like you, okay, this is like player 1 makes a move. Then there are like, let's say 5 moves are possible. Then there are like 5 other boards where player 2 makes a move, right? And then player 2 can make like maybe 4 moves here, maybe he can make 2 moves here, and then player 2 can make a couple of moves here, and then it's like a board where player 1 is making a move. So now what do we care about? Well, we're saying, how do we know what is the best move? This is a question. And the way we know what the best move is we can like sort of assume like a worst case scenario for ourselves. And that is that when we make a move and the second player is making a move, we're going to assume that they're going to make the best move for themselves. Or in other words, the worst move from our perspective. So now how can we code this up? Well, we're going to be looking at a board, who the next player is, whether it's us or the other player. And we're going to need to have some sort of way to evaluate how good a board is for us, i.e. how bad it is for the other player. This will get complicated later on when we want to make a game with more than 2 players. But for now, let's just look at this. So one thing we can do is we can look at all the possible moves. Like one simple way is say, look at all the possible moves. And out of these boards, which one is the best? And to figure out which one is the best, we need a way to evaluate these boards. Evaluate how good this board is versus this board. For example, if we have a board like this, we need to say that if we have like say 3 X's in a row for ourselves, this is a very good board for us. This is a much better board than a board where we have X's like this in a row. We need a way to evaluate that this is better than this. Now, if we had an evaluation function which could just like tell us the best move, that would be great. Like that would like evaluate the board perfectly. But what we're doing here is we're going to go deeper. We're going to say like, I have a function that can evaluate this board, but it's not that great. Because this is a computer, they can check out many different boards and do many different evaluations. So I'm going to push it to go deeper. And I'm thinking like here, I'll have a better estimate than if I'm here. And that's the sort of thing. For example, if your evaluation function is the best thing you can do is, count up the number of x's I have. Well, if you're just like going one level deep, then you can only see like the next move, and you can't really plan anything. Like the computer isn't quote unquote planning anything if it can just see one x down the line. But if it can go many x's down the line, then it can actually start, thinking about something. Like it can come up with deeper knowledge because it can see like, oh, if I play here, the best possible move will lead me to this situation. If the other player is playing the best possible game and I'm playing the best possible game, then it'll lead me to this situation. Do I want it? Yes or no? Like you can have a much deeper evaluation that way. So let's first think, how are we going to create this sort of evaluation function to evaluate a board? And the thing for me right now is thinking, if I'm the AI, I am going to do what? I'm going to just like count the number of 4s I have. I mean, if I have a 4 in a row, I win. But I'm going to see like if I have a 3 in a row, that's better than having 2 in a row or column or diagonal. And it's better than just having like one X that has just like O's around themselves. Now we could also count like where the O's are, whether there are any potential. But for starts, we can just like count how many X's are there going to be, so that we can so that our goal can be, put more X's, give us more potentials to win. So now let's do that. And actually, just seeing how long this video is by now, I think it's best for us to stop here. And we've created this sort of abstraction of the game. We can play the game with 2 players. And I think right now what we can do is stop, and I'll ask you to think about this. How are you going to make this? So the first thing, how can you make the evaluation function, a function that takes in, so it's an eval function that takes in, say, the board, and you need the sign as well. And then it gives you returns some score. That's between 0 or 1 or whatever. The range really doesn't matter. It just doesn't. The range doesn't matter. Say score is equal to something. I don't know. And then you return the score. And how are you going to calculate the score? Maybe you are going to go over all the possible, what's it called? You're going to count up all the 3s, 4s, all the 2s, 3s, and 4s. So maybe you go for row, for every row in board. Then you go for anything in a row. In the row, we're going to calculate how many of these things, how many elements with the same sign are next to each other. But I'm going to invite you to do that, and then next week we're going to continue off from here. And as always, thanks for problem solving.